Boom! Yes folks, how are you going? So welcome to another video as we continue our work on the CSEC mathematics syllabus. Alright, this is an introductory video to the whole topic of Cartesian coordinates, Cartesian straight lines, coordinate geometry, etc, etc. Alright, in this video I just want to take a little time to talk about the very basic fundamentals of coordinate geometry, the whole issue of the x-axis and the y-axis, the whole issue of the location of points on the x-axis and the y-axis. As simple and as straightforward as it is, we don't want to take anything for granted, most especially at the start. Alright, so to begin the discussion, we want to talk about the idea of locating a point in space. Now, if you think of something that most of us use on a regular basis, we have it on our cell phones. We have this thing that they call Google Maps. Some people use Waze, and there are a host of other similar types of apps that deal with location. So basically the idea is to locate your phone, to locate you, once you have your phone on you of course, and if you're using a map, you could locate any point anywhere in the world, not just in your own country, but in other countries in the world as well. Of course, this would be made possible by what we refer to as geostationary satellites, right? If the term sounds complicated, let me spell it out. Geostationary, S-T-A-T-I-O-N-A-R-Y. Stationary is A-R-Y. Stationary, E-R-I, is paper and pen and thing. Right? We have to be careful with the English even though we're doing maths. Alright? So you have these satellites orbiting the Earth up in space. They do the thing. And we could just use it on our phone and we have locations. But the central idea that underlies and underpins all of that is what I refer to as a reference point. There would be no ability to locate anything without a reference point. Alright? Let me explain what I mean. So, if I put this point on the whiteboard, and I ask you to describe the location of that point. You might say, well, it's high up on the board. But if from the time I say it high up on the board, you immediately introduce a reference point even though you don't recognize it. Because high up on the board is high up relative to something. High up on the board might be relative to the bottom of the board. Alright? You might be able to say it is below the top of the board. So in other words, the top of the board is a reference point. You might be able to say it is to the left of this side of the board, in which case you're using this side of the board as a reference point. Or you might say it is to the right of this side, in which case this side here is now your new reference point. So anytime you try to describe the location of something, understand that implicit in that is some reference point. You might even be aware of the reference point that you're using, but you're using a reference point. So to go back to the example of the Google Maps, anytime we have to locate a point anywhere on the surface of the Earth, you know they talk about latitude and longitude. Alright? And latitude and longitude is described with reference to a particular location, a particular point. We know that the reference point is the town of Greenwich in England. Again, one of those arbitrary things. There is no special reason why Greenwich was chosen as the reference point. I can't remember the exact story behind the choice of Greenwich as the reference point, but that ended up being the reference point. Excuse. So you have what we refer to as the Greenwich meridian, which is the line that runs straight through from the North Pole straight down. And then you have the equator, which runs, from east to west. All right? So to go back to our point here, if instead of just putting it on the whiteboard and having to use the edges of the whiteboard as our reference point, because that is the only thing we could use if we have to describe the location of this point. All right? Even if we take a ruler and measure the distance of the point from each of the edges, we're still using the edges as the reference point. We just have a more precise measurement of the location now. So instead of just saying, well, the closer the top of the board, we could backly measure it with a ruler and say it is how much ever centimeters from the top of the board. So measurement is just bringing a certain level of extra precision to the whole process. So if instead of using the edges of the board, I do this. So just as how we have Greenwich meridian in geography, this we could consider as our Greenwich meridian. We draw a line running from top to bottom. So if you could consider this whiteboard as the earth, surface of the earth, then this is your North Pole and this is your South Pole. All right? And then we do the same thing here. We run another line straight across. All right? This line would be like the equator on the surface of the earth. So you see I'm making a direct connection between mathematics and geography because it's the same idea. All right? So now we could describe this point by using this line as a reference point and using this line as a reference point. And in the middle of all of this, the point where these two lines intersect is the ultimate reference point. And this we refer to as the origin. Right? Now, I am not sure where on the earth the Greenwich meridian intersects the equator, but that might be a useful exercise for you, just to stroke your curiosity a little bit. So I want to suggest that as an exercise. Go on Google and check and see the exact point where the Greenwich meridian intersects the equator. So again, to continue with the geography analogy. So this we could make as the equator, and this would be your Greenwich meridian. Right? And this is your origin. I'm not sure where this point is, but check it out. It's somewhere. I suspect that it might be somewhere in Africa, if I'm not mistaken. Right where the equator runs in and where the Greenwich meridian is. Right? I will check it out, and then in somewhere along the line, in one of these videos, I will mention it. Right? But you can check it out for yourself too. So in geographical terms, this is a Greenwich meridian running from the North Pole to the South Pole. This is the equator running from west to east. All right? So in terms of the location of the Caribbean, we know that the Caribbean will be somewhere, I think it's 10 degrees north and 61 degrees west or something like that. So somewhere there, I think that is the coordinates of Trinidad and Tobago. I don't remember the exact location, and each territory in the Caribbean will have its own coordinates. All right? So in the same way that we could measure, in fact, no, I'll get to that a little later. Let me switch to the mathematical analog now, the mathematical analogy. All right? In mathematics, we refer to these two lines as coordinates. We refer to them as, in this case, let me switch up the colors a little bit now. In this case, we have the x-coordinate, the x-axis, sorry. This is the x-axis, and this is the y-axis, right? Normally, we would just have a y and an x, which you will see as you go further into this topic. All right? And this here is the origin. So I'm going to put this in red because we're using the mathematical terms in red now, as opposed to the geographical terms in blue. All right? And the same way that you have north latitude and south latitude in geography, and you have east longitude and west longitude in geography, in the same way that you have, it's the same way, sorry, that you have positive x and negative x. No, sorry, positive y. Look at the direction of the arrow here. So positive y is here, negative y is here. Positive x is to the right, negative x is to the left. All right? So in terms of the x-axis, this is positive and this is negative. And in terms of the y, your up is positive and your down is negative, right? There is no specific mathematical reason why up is positive and down is negative, why right is positive and left is negative. That is just one of those arbitrary things, right? In geography, of course, there is no positive and negative. It is just right and left, up and down. But for mathematical purposes, now we introduce the sign to signify, right? So down is negative, left is negative. Right is positive, up is positive. All right? So, in the same way in geography, the exact location of any place on the Earth's surface is given as a combination of latitude and longitude. All right, so let me use Trinidad and Tobago as an example. Right? If my memory serves me correctly, and I just go in with the little bit that I remember, the location of Trinidad is somewhere, let us say, I think it's like we see 10 degrees north. I'm trying to draw a Trinidad looking island there, right? Trinidad, I can't leave out Tobago. All right? Hey, we need to draw the thing out proper, man. I have a little thing in the bottom there. Bring out, right? Yeah, it kind of squashed down, but all I get the point, right? So Trinidad, I think generally speaking, is 10 degrees north and 61 degrees west, I think. West long. Somewhere thereabouts. Of course, there will be a little more precision in terms of how we describe. And I think the convention in geography is to use the location of the capital to denote the location of the country. And then within the country itself, you can get even more precise. So again, using the example of Trinidad. In fact, no, let me switch to Tobago. So even though the capital of Trinidad and Tobago is Port of Spain, the exact location of Scarborough, which is the capital of Tobago, will be a little different to the exact location of Port of Spain, right? It might be some fraction of a degree or some kind of thing like that. That's the general idea. But the general idea is that the location is given as a combination of latitude. In this case, it will be north latitude, north to signify that it is above the equator, and west longitude to signify that it is west of the Greenwich meridian. All right? In the same way, if I have to deal with the coordinate geometry system, then this point is given, the location of this point is given as a combination of the x-axis and the y-axis. So in other words, the location of this point is given as a combination of the perpendicular distance from the x-axis and the perpendicular distance from the y-axis. All right? So let us say for the sake of argument that the distance from here to here is, let me say 10, and the distance from here to here is, let me say 5. Then the coordinates, notice the language, the coordinates of this point would be, let us say 10, 5. Right? And then we, of course, we give the point a random name. The general random variable for points in the coordinates geometry system is P. So in the same way that you have X and Y in a regular algebra, anytime you're doing coordinate geometry and you have a general point, the general letter that they use is P. Of course, there will be other letters that will be introduced as well. If you have other points, R and S and T and V and all them kind of things. So 10 to the right, all right, along in the direction of the x-axis is 10, and 10, yes, and then 5 in the direction of the y-axis. That gives a precise location of the point. So now we could describe this point, having introduced a coordinate system. We could describe this point with reference to the x-axis and the y-axis, and ultimately we would be doing so with reference to the origin. All right? And all of this is just to give an introduction to coordinate geometry. Now, maybe you're familiar with it already, and that's fine, but I like to give these little talks just as a means of generating interest in the topic, of showing that the thing is not as random as they feel it is. All right? This same idea is used in geography, where instead of X and Y, we have latitude and longitude. It's the same principle. Is the same principle. The only difference is that here you're using a plane surface, a flat surface. And of course, in geography, because the earth is a sphere, everything will be spherical. And of course, the geometry of a sphere is a horse of a totally different color, to the geometry of a plane surface. So for example, the number of angles in a triangle is 180 degrees. That is true on a plane surface. That wouldn't be true on a spherical surface, because to begin with, by the very fact that the surface is a sphere, it means that the sides of the triangle wouldn't be straight. That means also that the angles wouldn't necessarily add up to 180 degrees. But that is a slightly different discussion. I just throw that out just by way of, again, connecting everything and demonstrate that everything is connected. So I'm not going to spend a whole set of time talking about this, also extra time, except to say that we have 4 quadrants. All right? We have, this is called the first quadrant. This is the second quadrant. So let me just write, right? My time running down here, and you will see, hold on, let me just take this off, because the alarm will go off any minute now. This is the first quadrant. So this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant, right? Right. How we do it, boy? I think we go so. Yeah, sorry, my mistake. The second quadrant is here. This is the second quadrant. This is the third quadrant. That will always be third no matter what direction you go in. And this is the fourth quadrant, right? Now all of this is not really important, but it's just extra information. All right? In this quadrant, the both coordinates will be positive. Now, before go any further, the x coordinate is always written first. Let me say that again. The x coordinate is always written first. Let me say it again. The x coordinate is always written first. So anytime I describe any location of a point, the first number is always the x coordinate. In the same way that when you're doing geography, the latitude is always given first, followed by the longitude. So everything has rules. Without rules, we'll just be in a whole set of disorderly chaos. It's like driving without traffic lights, everybody doing what they want, problems. All right? So with that, I will wrap up this video, and the exercises to follow after having gone through this particular discussion, you'll have a very clear sense of what the points mean if you have a point here, if you have a point here, if you have a point here, and if you have a point here. All right, so we could just continue and go on into the exercises.